Data protection and reliable backups are critical to any organization managing servers and applications. Manual backups are error prone and can lead to missed recovery points, inconsistent data states, or operational disruption. Automating backups ensures that critical data is preserved consistently, reducing both human error and administrative overhead. Hello everyone, I'm Sanskriti Harmuk, a developer relations at Vultr, and in today's Tech Talk, we will explore how to implement automated backup workflows using open source tools like Rclone with Vultr Object Storage. We'll walk through some key concepts, demonstrate how to set up reliable and incremental backups, and conclude with a practical demo showing how to keep your data protected seamlessly. So, without any further ado, let's jump right into it. Before the heavy lifting, let's touch on the basics first. Vultr Object Storage is designed to handle a wide range of workloads from lightweight log retention to large-scale database or media backups. Its flexibility extends not just to capacity but also to performance and cost, which is where storage tiers comes in. For example, the accelerated tier uses high-performance NVMe drives for write-intensive workloads. The performance tier is NVMe based and optimized for general data center workloads. Premium storage provides durable HDD with SSD indexing for general application, while standard offers cost-effective bulk storage with high availability. If you would like to know more about Vultr Object Storage tiers, then please refer to one of our previous tech talk labeled Getting Started with Vultr Object Storage tiers, linked in the description below. All of this is also fully S3 compatible, ensuring seamless integration with any S3 compatible client or workflow such as S3CMD, Python's Boto3 library, or even Rclone for backup operations. Data transfers are secured with HTTPS and encryption, ensuring your backup remains safe in transit or at rest. Relying on manual backups is risky. It is easy to miss a backup window or forget entirely, and this may lead to a serious data loss. Automatic backups removes that risk completely by running on consistent schedules without requiring intervention and ensuring predictable recovery points for critical systems. By scheduling regular snapshot, you know exactly what point in time you can restore from, which is crucial in minimizing downtime during failures. Also, automation is scaled effortlessly across multiple servers and environments. So, whether you are managing a single instance or a fleet of servers, automated backup workflows ensure consistent protection without increasing operational complexity. Now let's see how these automatic backups are implemented in practice using Rclone. Rclone acts as the core engine for automating backups, connecting server to Vultr Object Storage and transferring and synchronizing files efficiently. The process uses incremental copying, so only new or changed files are moved, reducing bandwidth and storage overhead. Further, scheduled cron jobs trigger these tasks automatically, eliminating the need for manual intervention and ensuring backups run consistently. Data is also encrypted in transit via HTTPS, and because Rclone supports S3 API, it integrates seamlessly with Vultr Object Storage. Now that we have covered the concepts and workflow, let's move into the demo. We'll see how to set up Rclone on an Ubuntu 24.04 server, configure it to connect to Vultr Object Storage, and run automated backups. During this demo, we'll perform manual backups first to validate the setup, then schedule automatic backups using cron jobs, and finally verify that files are correctly synced to the Vultr Object Storage. We'll start with a clean slate. The first step is to provision a Vultr Object Storage subscription, which will act as our backup target. From the Vultr Customer Portal, navigate to Object Storage present under Cloud Storage, and here click on Add Object Storage to provision a new subscription. Start by selecting the storage tier that best suits your needs. For this demo, we'll go with the premium storage, as this provides a good combination of high durability and performance. Next, pick a region close to you. We'll go with Delhi NCR. And further, provide a name to your subscription. Once everything looks good, click on Add Object Storage to finalize the setup. Now that our subscription is ready to use, click on it to access its management page. Under Overview, you will find three critical pieces of information: access key, secret key, and host name. All these credentials are fully S3 compatible, which means they can be easily integrated with any S3 based tools. including Rclone. To fetch all the S3 credential keys, click on this eye icon. It is always recommended to copy them and keep them somewhere secure. Now we need a bucket to store and organize our data files, which are often referred to as objects. For that, switch to the Buckets tab and here click on Create Bucket. Give your bucket a unique name. Optionally enable versioning if you want to maintain multiple versions of the same file. You can also enable Object Lock, which enforces write once, read many policy. This ensures that once a file is written, it cannot be altered or deleted, providing protection against accidental or unauthorized change. For simplicity in this walkthrough, I'll leave both these options disabled. Once everything is configured, click on Create Bucket. With our bucket created, let's now move over to our Ubuntu-based workstation where we will configure Rclone and set up our automated backup workflows. I have already installed Rclone on the system, but let's verify the installation by checking the version. As you can see, we are running Rclone version 1.71.0 on an Ubuntu 24.0464-bit server with a Linux kernel 6.8.0. This build is compiled with Go 1.25.0 statically linked for portability. These details confirm that the installation was successful and the environment is ready to configure the backup workflows. Rclone stores its configuration under your home directory. To check the default config file path, run this command. Since this is a fresh setup, the output will tell us that the configuration file doesn't exist yet, but it shows where Rclone expects it. So copy this path and open the file using nano, because this is where we will define our Vultr Object Storage configuration. Here replace the access key ID, secret access key and endpoint values with the credentials from your Vultr Object Storage subscriptions overview tab. Let's now quickly break down what each field here means. S3 storage is the name of the remote profile. Think of it as an alias. Every time we run an Rclone command, we'll refer to this storage target using S3 storage. Type tells Rclone to use S3 compatible backend driver. Vultr Object Storage follows S3 API standard, so this is required. Since Vultr isn't AWS but is fully S3 API compatible, we explicitly set the provider to other. Normally, Rclone can load credentials from environment variables. By setting this key to false, we are telling it only to use the keys defined in this config file. Access key ID and secret access key are S3 credentials generated by Vultr, which are equivalent to username and password for programmatic access. We are keeping the region field here blank because the endpoint itself encodes the region. This is the API host name for our Vultr Object Storage region. It's what directs Rclone to talk to a specific Vultr region. Location constraint is only used when creating buckets in some S3 provider. Since we already created bucket in the Vultr customer portal, this can stay blank. ACL controls the default permissions when uploading objects. Private ensures that every object you upload is only accessible to you unless you explicitly override it. Server-side encryption lets you enforce encryption at rest on the storage provider side. Since Vultr already encrypts object storage at the infrastructure level, this is typically left blank. Storage class define which storage tier to use. Since we already selected ours during provisioning, we'll leave this empty. Now that everything is configured, let's save this file and close it. To confirm everything is working, let's list the bucket inside our Vultr Object Storage subscription. The output shows the TikTok demo bucket we created earlier. This confirms that our configuration is correct and Rclone is now successfully connected to our Vultr Object Storage subscription. Before setting up an automated backup workflow, it's a good idea to validate the process with a manual backup. For that, we'll start by creating a test directory that simulates the data we want to backup. In production, this would typically be your application data, logs, or user uploads. To test the backup process, we'll create a couple of placeholder text files. These files represent the workloads we want to copy to our Vultr Object Storage subscription. Next, we'll use Rclone's copy command to transfer our project directory to the TikTok demo bucket we created earlier. This command recursively uploads everything from the project directory to a project folder inside our bucket. To confirm that the files are uploaded, let's list the objects inside the bucket. Since these are empty files, the size shows as 0. Now let's simulate a real-world change by editing test1.txt. Inside the file, I have added a short string that says greetings from Vultr. Let's save and close this file. We'll now run the same rclone copy command to sync the changes. Rclone is smart enough to only update the modified file instead of re-uploading everything. Finally, let's check the updated storage usage. The increase in size shows that our modified file was successfully updated in our Vultr Object Storage bucket. Now that we have tried a manual backup, you probably have noticed it can be repetitive and error-prone. In production environments, reliability comes from automation. To avoid missed backups and reduce human error, we'll integrate Rclone with Linux cron jobs to schedule recurring backups to Vultr Object Storage. Cron is the built-in Linux scheduler that executes tasks at fixed intervals. Its configuration is defined in etc cron tab. Open it with nano. Inside this file, each cron entry follows this structure. This breakdown defines when the job runs, which user executes it, and what command runs. To test the automation, let's configure a job that runs every minute. It copies the content from our project directory on the local machine to the project folder inside our TechTalk demo bucket. To adjust the backup schedule, you can simply modify the time fields in the cron expression. For example, setting the first two asterisk to 0 runs the backup every day at midnight. And if you also replace the last asterisk with 0, the backup runs every Sunday at midnight. Whereas, if you replace the third asterisk with 1, it runs backup at midnight on the first day of every month. Once done, let's save and exit the file. To see the cron job in action, create a new file in the project directory. This simulates a file that needs to be backed up. Cron logs all scheduled executions to syslog. Tail the log in real time while filtering for cron. Within a minute, you should see entries confirming that your job is running. Press Ctrl C to stop watching the logs once confirmed. Finally, let's verify if the changes are synced and our new file is now available in our TechTalk demo bucket. And tada! The output confirms that the cron plus Rclone automation works. Any file created or updated in our server's project directory will be automatically synced to the project folder present inside our TechTalk demo bucket in our subscription. You can also verify the sync from the Vultr customer portal. By navigating to the TechTalk demo bucket, you'll find the new test3.txt file in the project folder. These files can also be restored if in case your local copies get corrupted, and it can be done using the same rclone's copy command. But this time the source will be your S3 bucket's project folder and destination will be the project directory on the local machine. With this, we have completed a full backup and even restore cycle using Rclone with Vultr Object Storage. If you had trouble following any of the steps, you can refer to the supporting reference guide linked in the description below. And that wraps up our tech talk on automating data backups with Vultr Object Storage using Rclone. We have demonstrated how to set up, run, and verify reliable backup workflows, showing how automation can simplify operation and protect critical data. We highly encourage you to try setting up automated backups for your workloads on Vultr Object Storage. To get started, use the promo link attached in the description below to claim $250 in free credits on a new Vultr account. For further troubleshooting or to share your experiences, visit the Vultr Community Forum to connect with other developers and operators. Thank you so much for joining this Tech Talk. We hope to see you in the next one.